Go.
Hello, my name is Jose Franco. My lab partner is Mike Orr. Today we are going to be showing you the valve state simulation and the practical side of a Wheatstone bridge nightlight. Right here I have it demonstrated, as you can clearly see. As you scroll, this is the photoresistor right here. You scroll side to side, it'll activate and deactivate the LED. In order to make this properly, you need 3 resistors and a photoresistor added in here, and an LED right in the middle, bridging the gap. You would have them set up like this, as well as in the practical side. So right now we are going to show you how to calculate the total resistance for both the lowest side and the highest side of the Falstead photoresistor's resistance. Right here on the top side, we have it set up so for the lowest, in order to find the resistance, it's kind of tricky because you have to do 2 separate types of parallel circuit resistance in 2 separate sections, because they're connected, but they're technically not. So right here we have it set up as resistance in total equals 1 divided by 1 divided by R1 plus 1 divided by R2. Close that up, that's its own side. Then you do plus 1 divided by 1 divided by R3 plus 1 divided by R4. It seems like a lot, but in reality this is what it would look like. Super simple. 1 divided by 1 divided by 1000 plus 1 divided by 1000. That's this side again. That's this side. Then it's 1 plus 1 divided by 1 divided by 1000 plus 1 divided by 999, which is the lowest setting for the Falstead simulator for the photoresistor. When you do all the math and everything, it should come out to the total resistance for the lowest light resistance on this light resistor we have here in the circuit simulator. It would be equal 999.749 ohms. That is how you calculate the lowest end. So now, because it's a photoresistor, it will consistently change. It will never be the same type of resistance depending on the light, depending on how dark it is in the room, hence the night light. Now we're going to show you the highest resistance whenever it's completely bright out or you're shining a flashlight on it. So total resistance for a series parallel Wheatstone circuit nightlight for the highest light resistance it's the same concept that you would do up top. Same type of formula. Only difference is at the very end right here. So it's 1 divided by 1 divided by 1 divided by 1000 plus 1 divided by 1000. That's this side again. Plus 1 divided by 1 divided by 1000 plus 1 divided by 100,000, which would be this side if I was to put it all the way to this end. When you do the math for all of that all over again, you will end up with a total of 1,490.099 ohms. That right there is how you just get those two and it's good to know for the sheer fact, like I said, light resistors are never going to be the same. They're never going to stay like a normal resistor where it's 1K and that's a given. You're always going to have 100,000 or 1,000 resistance on that resistor. So now that I've shown you that, I can show you the practical side of it. Right here I have it built. So it's pretty much almost the same exact thing. Not exactly. 2 resistors in series, and then you got another resistor right here in parallel, right across. The light resistor right here, and then the LED in the center. The polarization of the LED matters a lot. All it takes is it being reversed, and you no longer have a night light. Now you have a light sensitive. So the more you shine light on it, the brighter it gets. Right now, I have it set up so that the positive end is touching the photoresistor, and the negative end is going to the resistors. So now, as I wire it up, go right there, Remember, this matters. Positive to positive, negative to negative. Lit up a little bit. Oh, my bad. So now, as you can see, me just putting my finger over it acts like it's darkness, which powers it up. Green LEDs are one of the hardest to light up too. Takes a lot more power to light them up. So, as you can clearly see, it's a night light now. It activates at night. All it takes is me doing this. Let's say I was to swap it upside to this way. Now, the positive side of the LED isn't even near the photoresistor. It's on the opposite end. Now, everything's still wired up. Nothing whatsoever. Now, if I was to have a flashlight at the moment, which I don't, my beautiful assistant does though.
Aw.
Watch. Clearly, it gets brighter. So, depending on the polarization, it's what will make it a night light or make it light sensitive completely. Whether, so that's really what matters. So, in conclusion, right here, give you the simulator version of what a Wheatstone bridge nightlight in a circuit simulator is supposed to look like if functioning properly. I've given you the total resistance for the lowest resistance on the simulator and the highest resistance on the simulator, showing you the practical side of it, what to do, what to trouble check at first. If let's say you don't think it's working right, whether it be a valid LED or you just gotta flip the polarization. That right there concludes my project. Again, my name is Jose Franco. My lab partner is Mike Orr, and thank you.